Hi, uh, let's talk about how will you write a program to check if given number, right? This is your number given, is prime or not. Okay, so first of all, you need to recall what's the conditions of a number being prime. So let's start. So prime numbers are the number which is either divisible by 1 or by the number itself, right? So I'll repeat again. Prime number is a number which has no other factors other than 1 or n, right? 1 or itself. Okay, so let's take an example. For example, 2 is a prime, 3 is a prime, 5 is a prime, 4 is not a prime because it has 2 and 2 as a factor, right? Similarly, 5 I already wrote, right? So 7, right? And then 11, right? And so on. So this is the property of prime. Okay, now how will you test this, right? How will you test this programmatically, right? So one way is like you can start dividing the number starting from 2 to n minus 1. This is the very naive, right? Naive solution. Okay, so you can start dividing by starting from 2. Start dividing the number by 2, right? You can write, sorry, this is n divided by 2 to, right, n minus 1. Okay, now what will be the complexity of that solution? So since you will have a loop to iterate from 2 to n minus 1, so the time complexity is going to be O of n in that case. Okay, this is the approach 1. Okay, so let's quickly code for this. Okay, so or let's discuss the other approach. Okay, so now the point is, do I really need to iterate from 2 to n minus 1? Okay, so for example, let's take an example. Let's take a number like 16. Okay, so in order to understand, in order to know if 16 is a prime number or not, what I have to do, I have to start dividing from 2, right? So 2 itself divides this, so it's no longer right, it's no longer a prime. Let's say we take a number as 17. Okay, so the same thing, we'll start dividing 17 by 2. I will check if it divides. No. We'll start with 3, then 4, then 5, then 6, 7, 8, 9, 10. I'm writing this for some purpose. Okay, 11, 12, 13, 14, 15 and 16, right? None of these numbers divide 17, right? So 17 will become a prime number. Now the question here is, do I really need to iterate from 2 to 16? Can I stop in between, or can I stop somewhere, right? Somewhere. Now, so let's consider, right? For example, let's consider you have a number. Let's suppose it can be factored into, right? It can be written as a multiplication of 2 other numbers, right? Now the values of x and y could be, right? It could be anything between 2 to n, right? 2 to n minus 1. Now what is the middle point of right, 1 to n? It can be root of n. Okay, why I come to the right middle point is like you can write n as x into x. Okay, you have x from here as well, x from there as well. So right, now the middle point would be like x square, so x could be root of n. Okay, this is your middle point. Now if let's say n is right, if let's say some number you have x which is greater than, so okay, now factor of these, right, and factor of n can be either greater than its square root, and another one has to be less than its square root. If any one of them is greater than square root, then other one has to be less than or equal to square root, right? So what I am proposing is, you should always iterate from 2 to square root of n. Okay, because if let's say this number x lies beyond root n, which means your y will be less than root n, right? So that's how it is, right? So if you see, if you consider the number like 1 to n, right, here is your root n, right? So let's say you multiply two numbers, right, from both are root n, so both will lie here, right? Now if you multiply both of them, you will get the value as n. Now the other possibility could be one number is like here, like it is greater than root n, so another one has to be less than root n. Okay, so what we are trying to find programmatically is, you have to iterate from, or basically 2, you have to iterate from 2 to root n. Till root n, if you are able to find a number, right, then only the n will not be a prime. If till root n you are not able to find any number which divides n, then you are good to go. It is going to be a prime number, right? So this is the n1, this is n2, right? So what we have to do is start iterate from 2 to root n. Now what will be the complexity of this solution? So again, time complexity will be something like, time complexity is going to be big O of root n, right? Okay, because we are not going beyond root n in this, and there is no extra space will use, so space will continue to be as big O 1. So remember, while solving any of the problem, right, you have to walk through this, you have to do these things, right, so that you will be able to formalize your logic, and you have to always provide the time and space complexity while right before start coding, right? So here also, in the previous approach, the time complexity was O of n, and the space I'm not going to use, right? Linear in n space, so it will be constant, right? Now let's code both of these two approaches, right, and in Java. Just a second, I'm setting up. Now, as usual, I'm going to write the code in terminal, right? So let's begin. Where is my terminal? Okay. Prime util, okay, .java. Let's start coding. Class prime util. Now let's take okay, let's write the method signature. So public, okay, since this is going to be returned, right, whether it is prime or not, so it will be boolean, right? Is prime. Okay, it will take a number, and this is going to be, let's write it right, naive, right, naive approach. I'm going to take the number as input, and then what I have to write, same, if num less than equals to, right? So prime, checking prime of negative number is as good as you check prime for its positive part, right? But prime number usually is positive, so I'll write a base case, like if it's greater than 0, in fact it's less than equals to 1, you are going to return as, right, it false. Okay, the reason is we don't consider, right, the prime number starts from 2. Okay, now next what I'm going to do, I'm going to write a loop which will start from this loop will start from 2, okay, and same, it will go till, right, num minus 1, right, or you can say less than num, right, which will be num minus 1, and then plus plus I. Okay, and what I have to do is, if num mod I equals to 0, whenever you got this, you just have to say that return false. Else, if everything ran and it reached here, then return true. Okay, this is the piece of code for the naive approach. Now let's write the main function for it the same. So public static void main, then how I'm going to execute this piece of code, right? So again, is prime native is a non-static function, so I have to create the instance of the prime util class. So let's create prime util object equals to new prime util object dot is prime, right? So native, right? Now let's say if provide 5. Okay, now so since this will return true or false, right? So what I have to do, you can write print this basically system dot out dot println number, right, 5 is number 5. We can write a logic here as well, right? And then is prime. Okay, it will print whether it is true or false. Okay, now and then that's it, is prime native. Okay, now let's test this. Java C prime util, what is the issue? Oh, it has to be plus, sorry. System out println method variable object of, oh, I think syntax some typing error, is prime naive, sorry, naive. Okay, Java prime util. Okay, so it is prime. Okay, now next, sorry, what I'm going to do is I'm going to change this to, right, 18, then I'm going to change this to 183.9 183.93939, right? Now okay, so again now we have to see some example of prime numbers also, otherwise, so we had already checked, right? Sorry, so let's take 17. Okay, okay, so this is, oh, it should return the prime as true, right? (17) 5, it should return prime as true. Okay, 5 it ran, oh sorry, I think I didn't change here, I changed it at only one place. Okay, so there you go. Okay, so it is prime and this false. Now let's quickly code the other piece of other approach. So as we know, this is linear, this has linear time complexity, right? Now let's code the other one, right? So another thing is same, public boolean is prime, and now if same num less than equals to 1, okay. Now next, so for int I equals to 2, I have to do a square root, right? So how will I do? Math dot sqrt and then num, okay. Now plus I. Now math dot qrt will be in the Java util. So I have to write the import statement, import java.util dot star semicolon, and then what I have to do? Same, right? If num mod I equals to 0, then return true. Now I'm going to call the other method with the same, right? Same input. This is prime and then is prime. Same. This is prime true, this is prime false, right? Now you are done with this, right? Prime util code. Sorry. Now the next, other set of questions can be asked in this is write prime numbers till 1 to 100. How many prime numbers are there, right? So for example, these type of questions can be there. So same thing, you can modify the same piece of code. You just have to write, for example, let's say okay, so you can write the same here, right? So we just have to modify this. So for let's say I'm giving a number, right? So for integer count equals to 1, 2, in fact 2, count less than equals to 100, count now if is prime of n, okay. Count is a bad variable name here, so I'm going to use is prime, okay. So is prime n, then what you are going to print is you are going to print, right, that number, and or let's say print it, okay. That's it. If it's not, it won't print, right? So same thing. Java prime util. What is this? Oh wait, this is very big mistake. My bad. I call this function without, because is prime is non-static, so I have to call this with same. It says, right, it printed all the numbers, all the prime numbers between 1 to 100. Okay, so that's it for this video. Thank you.